Hi everyone, my name is Isiki. So today we will continue the topic which is related to electric field due to continuous charge distribution. Hi everyone, in this video you are going to learn how to find the force exerted at the point charge which is located at the position 2, negative 3, 4 when you have two finite uniform line charge. So now let's go through the question together. So you have a two finite line, okay? So here you have one and here you have two, okay? So the second one we have calculated in our class, what is the total E, right? Okay, so later on we will directly use the answer. Okay, so you have two uniform line charge, okay? The first one is 9 nano, and second one is negative 8 nano that lie along the x and y axis. So finite uniform means you know the length of the line charge, okay? So determine the force. Okay, so the question is asking for the force, it's not the total E, okay? At the point charge, okay? At the locations 2, negative 3, and 4. So we have learned about the force before, right? Okay, so force is happen when you have two unit of Q, okay? So they are force between them. So now in this case, we have one unit of line charge and the second unit of line charge. So when we add up the total E between them, okay, when we add up the total E between them and we multiply the Q at the positions that we want to know the force, okay, so we will be able to calculate the force acting at the charge. Okay, so this is the concept. So we have calculated the E, okay, for the second line. So now we are going to calculate the E for the first line. Okay, so let's locate the observation point. Okay, locate the observation point first. The observation point is 2, negative 3, and 4. I expect 2, negative 3, and 4 is somewhere here. Okay, so the observation point is here. Okay, so remember we have to label A and B. So A is usually has a smaller values and B will have a larger value, and then we have to find, okay, we have to find the point T. Okay, so this point T will form a 90 degrees when you connect it to the point P. All right, so what is our point T in this case? So in this case, our y is 0. Okay, we are very sure. Z is also 0. And the x value will be following the x of our observation point. So it will be 2, 2, 0, 0, 0. Okay, so the first thing that we have to do is we calculate the distance vectors. So this is 2, negative 3, and 4, the observation point, and minus the 2, 0, 0, this is the point T. Okay, so we get 0, negative 3, and 4 as our distance vectors, and from there we can calculate the distance. So it's 9 plus 16, so it is 25, so square root you get 5. So the unit vector r is equals to 0, negative 3, 4, okay, over the 5. Okay, we can easily get this r. And then next we will be calculating the alpha 1 and alpha 2, right? So we are referring to the x-axis, and my line charge is from negative 8 to 7, so 7 is here, so negative 8 might be is here. Okay, so 0 is here. Oh, maybe I don't need a 0, but I need the observation point 2, negative 3, 4. Okay, so I make a line, might be 2, negative 3, and 4. If I'm plotting it against the y-axis, so 2, negative 3. So 2 is here, negative 3 is over here. It's over here, right? So if you rotate it, or is it very difficult for you to imagine? If this is the case, we try to plot it versus the z. Okay, so the z is 4, so z is 4 is somewhere here, right? 4 and 2. So now we can joining the point A and also the point B together with the point T. Okay, so we have P, we have a B, and we have the A point, and this will be the point T, right? Point T. Okay, so alpha 1 will be the angle connecting this with the line over here, alpha 1. And alpha 2 will be here, right? Connecting alpha 2. So let's find alpha 1 and also alpha 2. So for alpha 1, we will be referring to this triangle. We have a P, we have a T, and we have an A. Okay, so the length will be 10 units over here. And just now we have calculated the R is 5. Oh, our alpha 1 is here. So I'm going to use the tangents. So it's 10 over 5. Alpha 1 is equals to 63.43 degree. Okay, next we look at the alpha 2. So alpha 2, I will be using this triangle, my P, my T, and my B. Okay, so this is alpha 2, this is 5 unit. Okay, so from T to B is 5 unit. Okay, so tangent alpha 2 is equals to 5 over 5. So your alpha 2 is 45 degrees, right? Okay, degrees. So now let's look at the rotations of the angle. So alpha 1 is clockwise, so it will be positive. Okay, so alpha 1 will be positive 63.43 because it is anti-clockwise. Whereas for the alpha 2, it is clockwise direction, so it will be negative, so it's negative 45. Okay, so now we go back to the equations. So this is the general equations, okay, that we have to use when we are calculating the electric field due to line charge. We have negative sine alpha 2 plus sine alpha 1. So we have the R. And then we plus the cos alpha 2 minus the cos alpha 1. And in this case, let's look at the directions or the axis that we have our line charge. So the line charge is located along the axis X. So this is going to be X, right? Okay, so now let's replace everything that we have. So the line charge is 9 nano. So 9 nano over 4 pi epsilon naught. And the R equals to 5. Negative sine alpha 2 is negative 45 plus sine 63.43. And then we have our unit vector R is equals to 0, negative 3, 4, 0, negative 3, 4 over 5. Yeah, okay. And plus the cos alpha 2 is negative 45 minus the cos 63.43 and the X. Okay, so we have everything in the equations, so we have to calculate now. So this is 16.18. Okay, negative sign. So we have 1.60, 1.60, okay, 1.6, okay, and then 0, negative 3, and 4, and 5, okay, and plus So this is cos. So this is 0.2226x. Okay, right. So now I'm going to multiply this, okay, and consider this also, and then multiply it, okay, for every term because they are x, y, z is a vectors. So I have a 0x plus minus 15.53 y, and then plus 20.71 z, and plus 0.26x. Okay, so basically I can ignore this one. So this is the electric field, which is contributed by the first line charge, okay, the E of the second line, I would say that it's the first line, okay. So the E, okay, from the second line, we have calculated in our class, so you can refer this, right? We have calculated this one, right? Okay, the same observation point, the same line charge. Okay, so the answer is this. Okay, so the answer is this one, so you are going to get this. So I'm going to get this. I'm going to copy it, and then I'm going to paste it here. Paste. Okay, so the E2 is here, right? Now we have to sum them together to find the E total. We need this E total. So X would be, so is negative 1.18. Okay, this is the X. And for the Y, it is 10.06. And for the Z, is 17.83. See, so this is the E total. So we managed to find the total electric field at these positions. Now imagine I suddenly top up these positions with a point charge, which is 5 nanocoulombs. Okay, you are going to find the force acting on this point charge. Okay, acting on this point charge. So the formulas that you have to use is getting the E total and multiply with the magnitude of the Q. Okay, so the magnitude of the Q is what again? 5 nano. 5 nano. So you multiply with all this term here. They will use this 10.06, 17.83. Okay, so 5 nano. Okay, so it is 5.9, okay, nano. Okay, so 50.3 nano. So 89.15. Okay, nano. And the unit of the force is Newton. So this will be the force, okay, that is acting at the point charge.